Route optimization by using anonymous car tracking data. The project objectives. Nowadays, one major issue in our day-to-day lives is the huge amount of traffic that we have. Due to this large amount, many people are taking a very long time to arrive at their destination. The objective of this project is to find the optimal route to the destination for the driver. For the route to be optimal, it needs to be the shortest route whilst avoiding traffic. To find the traffic locations, the car location data could be obtained from the phones of the drivers themselves. Using this real-time location data received, the optimal route should be plotted. Moving on to the studies. So, the first study is capacitated vehicle route problem model for scheduled waste collection and route optimization using PSO algorithm by M.A. Hanan et al. In 2017. In the study, M.A. Hanan et al. Tried to find the optimal route for waste collection vehicles. To find the optimal route, smart bins were used. These smart bins use sensors and gave out real-time data. The data being sent by the smart bins was whether the bins needed to be emptied or not. In the study, the particle swarm optimization, or PSO algorithm, was used. This algorithm is based on behaviors of flocks of birds searching for food. M.A. Hanan et al. Used the PSO algorithm to find the optimal route at different velocities. In this study, ArcGIS was used to obtain the real-time bin data. The two best values from all the different iterations were kept until the true optimal solution was found. M.A. Hanan et al. Say that the algorithm proposed showed very positive results. The study was relevant to the project being conducted because it describes how the PSO algorithm could be used together with ArcGIS to find the optimal route. The next study is connectivity-based optimization of vehicle route and speed for improved fuel economy by Chen Sheng Benoit et al. In 2018. The purpose of the study is to optimize vehicle route and speed simultaneously using traffic data and vehicle characteristics. This was done to improve fuel economy. To get the data, methods based on vehicle connectivity were used. Examples of such methods are vehicle-to-vehicle communication and vehicle-to-infrastructure communication. In the study, a cost function to find the fuel consumption and emission was established, and the mathematical model based on directed graphs and mixed integer linear programming was formulated. Chen Sheng Minowa et al. Used genetic algorithms, or GAs, to find the best route. To test the route, the authors ran a speed-oriented simulation on fixed routes at different time limits on each route. The best routes were considered the shortest and fastest routes. According to Chen Sheng Noah et al., this method worked since they managed to reduce fuel economy by 15%. The study was relevant to the study being conducted because even though the study was placed to reduce fuel economy, it showed that genetic algorithms could be used to find the optimal route. The third study is route optimization for electric vehicles based on dynamic wireless charging by Dimitrios Kosmanos et al. In 2018. The objective of the study was to find an optimal route for electric vehicles while charging along the way to the destination. The study takes into consideration the amount of battery the car has and the locations of both dynamic and static car charging points. In the study, Dimitrios Kosmanos et al. Used the Dijkstra algorithm. If the shortest route satisfies the drive, which means that the car can arrive to the destination without needing to charge, then the algorithm is not even considered. The algorithm does not even consider charging. Otherwise, the route needs to have either a static or dynamic charging point along the way. To find the best charging point, the total travel time, time in traffic, charging time were all considered. The locations of the charging points were also considered. This was to find the best point with the amount of charge left in the car. Dimitros Kosmonos et al. Explained that this study was successful and that the more charging the car needed, the longer the travel time. Similar to the previous two studies, the study was relevant because it shows that another algorithm, in this case the Dijkstra algorithm, could be used to find the optimal route. Moving on to getting the location and studies around it. The first one is real-time location-based tracking using Wi-Fi signals by Atul Gozai et al. In 2014. In this report, Atul Gozai et al. State that some real-time tracking systems use access points or location receivers. The access points and location receivers detect tags and Wi-Fi devices in the nearby areas. The two methods to find location over Wi-Fi are time difference on arrival, or TDOA, and received signal strength indicator, RSSI. In TDOA, the location is found by calculating the time it takes for a packet to be sent and received by a transmitter. When three access points are used, the triangulation method is used, and this has an accuracy of less than 5 meters. When using RSSI, the device of the user measures the strength of the signal and sends it to the server. The server then calculates location based on the data received. This study was relevant to the project being conducted because it shows how methods using Wi-Fi, which are TDOA and RSSI, could be used to find the location in real time. Another study was Low-Cost Mobile GPS Tracking Solution by Rajkishan Molu et al. In 2011. Rajkishan Molu et al. Managed to create a low-cost mobile GPS tracking solution. For this to work, Rajkishan Molu et al. Created an application based on PHP, MySQL, Google APIs, and J2ME, which is Java 2 Micro Edition. This application had to be installed on a device with a GPS for it to work. Then the application sent the real-time data received from the GPS to the servers. The study was relevant to the project because it shows that the GPS system could also be used to retrieve real-time location data. The project design and implementation. After reviewing these studies, the study by M.A. Hanan et al., in which the PSO algorithm was used to find the best route for waste collection vehicles, was found very useful. This is because in this study, the real-time bin data was used to find the best route. This was so that the route could be plotted in such a way that the waste collection vehicle should pass from certain roads and not from others, which is really similar to the idea being proposed in this project, which is to avoid traffic by passing from other roads. Another study that was found to be useful was the study by Dimitros Kosmanos et al., in which an optimal route for electric cars was to be found, so that the vehicle could arrive at the destination taking into consideration charging along the way. The study was found useful because it is very similar to the study by M.A. Hanan et al. However, it shows that it could be done by a different algorithm, the Dijkstra algorithm. When it comes to real-time location data, the study by Rajkishan Molu et al. Was found very useful since it uses GPS on the device itself other than relying on access points or location receivers. The implementation of the project would be the combination of the studies found. So to recap, this project is to find the optimal route to a destination, meaning that the optimal route should be short and avoid traffic. The first route optimization study showed how the PSO algorithm could be used to find the optimal route for waste collection vehicles. The second route optimization study showed how GAs could be used to find the optimal route to reduce fuel economy. And the final route optimization study showed how the Dijkstra algorithm could be used to find the optimal route for electric cars, taking into consideration charging along the way. The first real-time location study showed how methods using Wi-Fi, which are TDOA and RSSI, could be used to find the location in real time. The last real-time location study showed how a GPS system could be used to retrieve real-time location data. And the implementation of the project, as I said earlier, would be of the combination of the studies found. Thank you.